Hi everyone. Today I'm going to talk about statistics and machine learning and AI. The table of contents would be introduction in AI and machine learning, and statistics and machine learning, types of machine learning, supervised learning, unsupervised learning, and reinforcement learning, and side effect of machine learning. Before we go, I want to introduce about me first. So about me, my name is Gijun Park. You can call me Park or June. I'm a currently statistic major, and I'm a treasurer of this club and an ICC delegate. I'm also a TA for Math 2 class, which is pre-calculus for Professor Ramsey. And I was in a military in South Korea for about 18 months. So before we start, the goal of this workshop is to understand the fundamentals of machine learning and explore the connections between machine learning and statistics. And also, we want to identify the applications of AI and machine learning and understand the key techniques of machine learning. So we always talk about AI every day, but what is AI? So we call an AI that performs tasks typically requiring like human intelligence. So typically we want the computer to do like problem solving and learning, perception, and decision making. So by AI, we want our life more better quality. And yeah. So AI is used in a lot of areas, like in healthcare. We can predict disease infection, and we use AI for drug development, and also in finance. We use in fraud detection and stock price prediction. We also use in retail, like customer recommendation, like Amazon and Netflix. House of Cards are based on Netflix recommendation AI. And autonomous vehicles such as Waymo and Tesla. Also voice assistants like Siri and Alexa. I have a short video that talks about AI, so I'll show you. This was an ad from NVIDIA that makes chips for artificial intelligence and computers. Besides that, what is machine learning? So machine learning is method of teaching computers. So we need a data, and the goal of machine learning is we want the computer or maybe another machine to learn from data, and without like we don't need to command everything and program everything. We want them learn alone. The difference between machine learning and AI is at the table. AI has like a broader field that like to create machines like mimicking human intelligence. Besides that, besides AI, machine learning is like a subset of AI that is teaching, a method of teaching computers. The goal of AI is we want the computer to task like human or maybe a robot. But machine learning is we want to teach it automatically from data. And it may, and some AIs may just work with a lot of codings, like a lot of rule-based systems, but machine learning definitely need data. IBM's Deep Blue, which won the chess champion at 1998, was basically all of codes and wasn't had any machine learning techniques. But currently, Netflix recommendation system and Tesla's FSD and current artificial intelligence use a lot of machine learning. So machine learning and statistics are really relative. The foundation of machine learning is from statistics. We use a lot of statistical concepts to interpret data and measure performance and estimate the uncertainty. So there are some statistical concept that is used in machine learning, such as mean, median, variance. Mean means the average, and the variance is it's a method that when we calculate the dispersion of the data. And clustering, we can use to group data by features. And hypothesis testing, it helps us to determine decisions. And linear regression, it helps us to predict from the data automatically. So there are three types of machine learning. There is supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is we give labeled data such as dog and cats, like a photo. We labeled it, and then we give the computer to train it to identify it. And then eventually, when we throw unlabeled data of like photos of dogs and cats, we want the computer to identify if it's a cat or dog. One fun fact is before 2012, a computer could not distinguish between cat and dog. So it's kind of remarkable how computation advanced. We use a statistical method called classification in supervised learning. So it's basically the same method of cats and dogs that I talked about. So we label the data first, and then the model tries to predict the correct label of the input data. The key point is the variable should be discrete. So it should be spam or not spam, or it should be like how many people's. It cannot be like a temperature that is continuous. For classification, we can use in medical image diagnosis. So, but when we throw like brain x-rays or something, they can detect disease like tumor. Or also in spam detections, like classifying them as spam or not. And sentiment analysis. By some like Google reviews, they can just automatically know by positive, neutral, negative, and face recognition. So like identify individuals of like photos and videos. There's another statistical concept we use called linear regression. It's kind of a bit hard concept. So what is linear regression? So linear regression models the relationship between response variables as the price of house. So response variable, which is the target variable, is like the price of house. And it has another explanatory variable, such as number of rooms or location. For example, if the house is in Manhattan or like Santa Monica, it will be expensive. So, and then we make a linear regression model, like equation. And then by that, we can predict the target variable, which is the house, like such as the price of houses. We usually use when the target variable is continuous, such as price, weight, height, temperature. Also, this dots are each data points. So for example, if the y value of this y value is higher, it means it's expensive, and this is the x value, so it has less rooms. And for here, it has a lot of rooms with higher prices. We use linear regression when we predict the house prices, or stock market prediction, like we predict like the option price or stock prices, and sales forecasting, like we predict future sales based on past sales data. You also can use linear regression for medical cost estimation. You can predict healthcare costs based on factors like age, weight, and pre-existing conditions. So I made a simple linear regression equation with top 10 NASDAQ stocks. Before we make a linear regression equation, we got to define variables. So I let X as a 5-year average earnings per share growth rate, which is how fast the company grows. And I let Y as a PE of the company. So PE is basically, we can think as how much it is like valued. If the PE is higher, we can say the company is very expensive. And I put the data in the calculator. So this point is Costco. It has about 8% of growth rate, about 5 years. And then the 4 PE, which is the price, is about 55. This is Meta. This is it has about 13% of growth rate, and then it's priced kind of cheap. This is Tesla. This is Nvidia. And I eventually got an equation of y equals 0.41x plus 29.63. So how do we use the equation? So we can interpret. So if there's like a imaginary company with an annual growth rate of 10% and the EPS is about $10, is listed on NASDAQ, we can say that fair PE, which is the price, can be 33.73, and the rational price can be 337.3 per stock. And there's another method called unsupervised learning in machine learning. The key point of unsupervised learning is we do not label the data. So we just throw any data to the computer, and the computer identify the features. So we throw star, triangle, and like star, triangle. And then eventually when we throw a lot of data to the computer will automatically distinguish, like gather group stars and triangles. The key point is we do not label the data and we do not give any feedback. We use a statistical concept called clustering. So you can just think as just grouping that data points are similar. We use clustering in customer segmentations. Like we want to do like a target marketing to like a kids and or maybe like toys. So we want to know who buys a lot of toys. Or document grouping, such as like we throw like articles and research, and we want to know like what is entertainment, what is sports, and what is technology articles. And urban planning. Also social network analysis. So we cluster users by like social media, who watches like Mr. Beast more or who watch some YouTubers more. One type of clustering is k-means clustering. So I'm gonna show how it works. Before we start k-mean clustering, we gotta label the x and y axis and data. So I let x as a total spends on something like groceries, and I let y as an age group. So this people is old. This data point is representing a person who is old but who do not spend a lot of money, and this person is old as too, but he spends a lot. And we gotta decide how many clusters we use, and we gotta pick random points. At this time, I picked 3 clusters. And then I assign each data to the nearest point. We gotta know which data point is the closest. We can use the Pythagorean theorem, like radical a squared plus b squared. And then we assign every data like this. And after that, we gotta calculate the center of each group. The center of the red point will be like this. The center of the yellow point will be like this. And the center of the blue point will be like this. And we keep do this process again and again till each data point is confirmed and each data does not change even though we do it again. And the last type of machine learning is called reinforcement learning. So reinforcement learning is a type of machine learning where there's an agent, which is the computer, learns where an agent, and they make any decisions and in an environment, which is like a situation. If the agent takes like any decisions or actions, we observe the results and we give a feedback, like a reward. Like it performed well, it performed not well. And the eventual goal is to maximize the total cumulative reward. So we want the computer to reach some point to be as fast as we can. We use reinforcement learning and game AI. So there's like a Go computer that plays like AlphaGo, or robotics. This is Tesla's Optimus. And self-driving. This came out recently, about like 10 days ago. And one of the fun fact is recently the DeepMind CEO, which made the AlphaGo robotics, artificial intelligence, has won the Nobel Prize of Chemistry for developing an AI called AlphaFold, and it can predict the structure of protein, like these proteins. We use a equation called Bellman equation from statistics when we use reinforcement learning. So what is Bellman equation? It's an equation to help to estimate the expected cumulative reward. So it's kind of hard to like comprehend, but I'm gonna break out by small. Before, I want to declare some terms. Agent is the learner or decision maker, like a robot. And action is a choice or decision that the agent can make. And a state is the current situation that the robot has. And the reward is the feedback, like coins or like something. So if we interpret the equation, V of S equals the value of the current point. And then R of S and A is the reward at the particular state by performing an action. And this gamma is the discount factor. And V of S prime is the value of the previous stage. And the max is maximum. So I'm going to apply this equation by a simple path. So I made like a maze for a robot, and I want to calculate every values by Bellman equation. So when it follows the higher value, we want to reach the robot to reach smile. Before, I gotta let gamma equal 0.9. You can let gamma equal 0.8 or 0.7. I let the reward smile as 1 because I want to reach here. I let band reward as -1. So when we calculate the value of the current situation, we start from the nearest endpoint. So I started from S1. When the robot is at here, it can make a decision to go S8 or S2 or smile. But we want to maximize the value of the equation, so I'm going to choose the higher one, which is 1. So at this equation, I let the reward as 1. And since there is no previous value or previous stage, we do not calculate it. So the S1 value is 1 by the Bellman equation. And in S2, even the robot is at S2, even they can go to S1 or S3 or to the water. It does not get any rewards. It only has a value of 0. So we only calculate the previous value, which is 1, and we multiply with the gamma, which is the discount factor. So 0.9. S2 has a value of 0.9, same as S3. S4, S5. But at S6, it's kind of different. Because at S6, you can let the previous stage as S5 or S7. But if you choose S5, the robot will go like this, and then the previous value will be smaller than S7. So I'm going to calculate S8 first. S8 comes out with, at S8, the robot do not get any rewards. It can get a -1 or 0, but I'm choosing the maximum. So the previous stage will be 1, and I multiply by the discount factor. Goes on, S7. At S6, again, I can choose S7 as a previous value or S5 as a previous value, but I'm choosing the maximum point, so I'm choosing S7 as a previous value. So we can calculate every values of the situation. And if we interpret this, when we place a robot in any place and make the robot follow the higher values, it will reach this mile and the shortest route. There are some side effects of machine learning in AI. Which one of this is bias. It can be biased by training data, such as like some financial algorithm can charge like a higher interest rate towards like a certain race because certain race has lower credit scores. It can have overfitting or underfitting. So overfitting is like, think as like when we throw like a cat and dog and we want to choose a cat, but the computer thinks dog photo as a cat because it got too generalized. And underfitting means even though we throw the cat photo to the computer, it cannot catch as a cat photo. The computer cannot. And it can make a recursion. It goes on and on because the data is limited and it only learns from data, which has no creativity like humans. Okay, thank you.